Hi, I am Devesh Banerjee, lecturer of Electronics and Telecommunication Department. Today I discuss the topic about sampling condition, aliasing effect. Good morning to everyone. I am Devesh Banerjee, lecturer of Electronics and Telecommunication Department. Today I discuss the Nyquist rate. In previous lecture I already told the sampling theorem, which is Fs greater than equal to 2 Fm, where Fs is the sampling frequency and Fm is the maximum frequency present in the sample. So this is the sampling theorem. Okay, today I discuss the Nyquist rate. Okay, what is the Nyquist rate? What is the Nyquist rate? When the sampling rate becomes exactly equal to the 2 Fm samples per second, then it is called the Nyquist rate. Means when sampling rate is exactly equal to the 2 Fm sample per second is called the Nyquist rate. Means Fs equal to 2 Fm. This condition is called the Nyquist rate. This is called the Nyquist rate. Okay. The scientist Nyquist discovered this formula, so it is called the Nyquist rate. Okay. So what condition for Nyquist rate? Fs equal to 2 Fm is called the Nyquist rate. This Nyquist rate is also called maximum sampling. This Nyquist rate is also called minimum sampling rate. It also called minimum sampling rate. Okay, so Nyquist rate is also called the maximum sampling rate. Next we discuss Nyquist interval. Nyquist interval. Maximum sampling interval is called the Nyquist interval. Is called maximum sampling interval is called Nyquist interval. Is called Nyquist interval. Interval means time. Nyquist time. It also represented as time domain, or it also represented in second, or represented in time. So this time is called the Nyquist interval. So Nyquist interval is denoted by Ts, because it is related to the interval, means it related to the time. So Ts is equal to 1 by 2 Fm. The unit of the is second, because this is called the Nyquist interval. Okay, because it is related to the time and frequency. T is equal to 1 by F, and T is called the time and F is called the frequency. So here the Nyquist interval is denoted by Ts, which is 1 by 2 Fm, and the unit of Ts is second, so it is called the Nyquist interval. So first I told you Nyquist rate, then I told you Nyquist interval. Okay, next I discuss condition for sampling. Condition for sampling. Okay, there are three types of condition for sampling. Okay, so three condition. What are the condition? Now fs greater than 2 fm, it is the first condition. Second condition is fs equal to 2 fm, and third condition is fs less than 2 fm. Okay, fs, the condition for sampling means the continuous time signal converted into discrete time signal. For what condition? There are three conditions: fs greater than 2 fm, fs equal to 2 fm, and fs less than 2 fm. So we consider the first condition. First condition is fs greater than 2 fm, and it obey the sampling theorem principle. This condition obey the principle of sampling theorem. So the successive cycle of g omega means frequency spectrum, are not overlapping each other. Okay, g omega means which g omega? This is the g omega. Okay, this is called the g omega. The frequency domain of sampled signal is called the g omega. So g omega are not, this successive cycle means this cycle and this cycle are not overlapped each other. Okay, for condition fs greater than equal to 2 fm, the successive cycle are not overlapped of each other, and no problem in recovering the original signal. Okay, and no problem, we easily recover the original signal from this spectrum. So the diagram is, this is the g omega and successive frequency spectrum. This is the successive frequency spectrum, and at the first spectrum, this is the second spectrum. Okay, this is the middle spectrum, and this is the right side of the spectrum, and this is the left side of the spectrum, but this spectrum are not overlap each other. So this is 0, and this is omega s, and this is the minus omega s. This condition fs greater than equal to 2 fm. Okay, the second condition is fs equal to 2 fm. The second condition, fs equal to 2 fm. So what happened when the fs equal to 2 fm? G omega are not overlap. Okay, but they are touching to each other, but they are touch to each other. Okay, they are not overlap, but they are touch to each other. So the diagram is, this is the g omega. Okay, and this is the middle spectrum. Okay, and this is the right side spectrum, and this is the left side spectrum. So this spectrum is touched but not overlapped. Okay, this is the condition for fs equal to 2 fm. So this is the 0, this is the omega s, and this is the minus of omega s. Omega s means fs, and this is the minus of fs. because in the omega the frequency is present, this is the second condition. And next, the third condition is Fs less than 2 FM. The third condition is Fs less than 2 FM. So G omega will overlap each other. G omega will overlap each other. Okay. And X omega means original spectrum cannot be recovered, and original spectrum cannot recover. Okay, because they are overlap to each other, so the original signal cannot recover. So the diagram is, this is the G omega, this is the middle spectrum, and overlap, this is the right hand side spectrum, and this is the left hand side spectrum. So this portion is overlap to each other. Okay, this is the omega s, and this is the minus of omega s, and this is the 0. So at this condition, Fs less than 2 FM, the spectrum overlap to each other, so the original signal cannot be reconstructed from this figure. Okay, so we consider to convert continuous time signal to discrete time signal must be Fs greater than equal to 2 FM. So these two conditions, Fs greater than 2 FM or Fs equal to 2 FM, this called the sampling theorem. And at this condition, the original signal can be recovered and the spectrum will not overlap to each other. Okay, so we consider Fs greater than equal to 2 FM, which is called the sampling theorem. Next we discuss the reconstruction filter. The reconstruction filter. Okay, basically the reconstruction filter is used to recover the original message signal. So recover the original message signal. Okay, reconstruction filter is used to recover the original message signal. Basically a reconstruction filter is a low pass filter. Okay, so a low pass filter is used to recover original signal from its sample. Recover original signal from its sample. Okay, reconstruction filter basically a low pass filter which recover the original signal from its sample. So the characteristic of ideal low pass filter is, the characteristics of ideal low pass filter, you have already told you have already read the low pass filter in network analysis. Okay, so low pass filter means which passes the low frequency and block the high frequency, and this is the characteristic. This is the ideal characteristic of low pass filter. Okay, this is the ideal characteristic of low pass filter. But in practical, low pass filter characteristic is this is the practical low pass filter. Okay, and this is the ideal, and this portion is ideal, this portion is ideal, but this portion is practical, means ideally it is passes the low frequency and block the high frequency, but practically it passes low frequency but a small high frequency is also passes. Okay, this is the practical low pass filter characteristics. But in frequency spectrum, the original frequency spectrum or message signals frequency spectrum is this. Okay, this is 0, this is FM, this is the minus of FM. This is the original signal spectrum of original signal spectrum. Okay, so we consider the original frequency spectrum fs greater than equal to 2 fm. This is the g omega and this is the pulses, sample pulse. Okay, this is the sample pulse, this is 0, this is the fm and this is the minus of fm. Okay, so the low pass filter passes, this is the original message. Okay, and the low pass filter recover the original signal from its sample, because this is the sample original signal and its sample. So the low pass filter is used to recover these signals. Okay, so this is the characteristics of low pass filter or frequency response characteristics of low pass filter, because this portion is recovered or this portion is passes through the low pass filters and other samples is blocked. So this filter is called the reconstruction filter or low pass filter. And next, the important topic is aliasing. What is aliasing? Aliasing. Okay, aliasing means aliasing occurs when fs less than 2 fm. For this condition, aliasing occurs. Aliasing means at the condition of fs less than 2 fm, what happened? Because the sample pulse is overlap to each other. This sample pulse is overlap to each other. Okay, this is the overlapping portion. This is the g omega. Okay, so this is the 0. Okay, this is the fs, this is the twice of fs, and this is the minus of fs, and this is the minus of twice fs. Okay, so this portion is called the aliasing because they are overlapped to each other at the condition of fs less than equal to 2 fm. This called the aliasing. This condition is called the aliasing. Okay, aliasing is occurs when fs less than 2 fm. Okay, aliasing is occurs. So aliasing is a phenomenon in which high frequency component takes the identity of a low frequency component. High frequency component takes the identity of low frequency component. Okay, high frequency component takes the identity of low frequency component, means the low frequency component is mixed with high frequency component, so we cannot recover the low frequency component from high frequency component. So this phenomenon is called the aliasing. Okay, so at the aliasing is when the aliasing is occurs, we cannot recover the original signal Okay, because the high frequency component takes the identity of low frequency component, means low frequency signal is mixed with high frequency signal, so we cannot recover the low frequency signal, which is called the message signal. So prevent the aliasing effect. To prevent the aliasing effect, first the signal passes through a low pass filter. To prevent the aliasing effect, the signal first passes through a low pass filter. Okay, because if we use the low pass filter, the high frequency component is blocked and passes the low frequency component, and this low pass filter and this low pass filter, so the low pass filter is called pre-aliasing filter, pre-aliased filter. This low pass filter is also called pre-aliasing filter. To prevent the aliasing effect, it is used to prevent the aliasing effect. So what is the aliasing effect? Aliasing effect is occurs. What is the aliasing effect? Now when the high frequency component is takes the identity of low frequency component, means low frequency component is mixed with high frequency component. When it is occurs, when Fs less than 2 FM, it occurs when Fs less than 2 FM condition, means this is called the aliasing. So at this portion we cannot recover, because it is the mixture of this spectrum and this spectrum. This portion is mixed with this spectrum and this spectrum, so we cannot recover from this portion, we cannot recover this portion. So to prevent the aliasing, to avoid the aliasing, a low pass filter is used, and the signal is first passes through a low pass filter. Why first passes through a low pass filter? To prevent the aliasing, because the high frequency component is blocked by the low pass filter, and low frequency component is passes through the low pass filter to prevent or to overcome the aliasing effect. So for this reason, the low pass filter is called the pre-aliasing filter. Okay, thank you to everyone.